Welcome to Study Loop.
So the first thing we want to do is find the volume of the cylinder, which the volume of a cylinder is pi r squared L. And so that equals pi times 10.0 centimeters squared times 20 centimeters, which gives us 6283 centimeters cubed, which equals 6283 milliliters. And since 1 milliliter is 1 centimeters cubed, now we want to take our 6283 milliliters and subtract 25 milliliters, since that is displaced, and this will give us a volume of air in our cylinder, which is 6.258 liters. And I converted to liters by dividing the answer by 1,000. And so now we can use the ideal gas law, PV equals nRT, to find our number of moles of air. And so our pressure is 760 millimeters of mercury, which is 1 atmosphere. Our volume we just found to be 6.258 liters. Our number of moles are unknown, and our R value is 0.082057 liter atmospheres per mole Kelvin, and our temperature is 298 Kelvin. So we rearrange this equation to solve for N equals PV over RT. And we plug in all of our values, and we get that we have 0.2559 moles of air. And now we need to find the total moles. And so there's air and nitrogen in this cylinder. And so now we can find our moles of nitrogen. We have 25 milliliters. The density of nitrogen is 0.807 grams per milliliter. And then the molar mass of nitrogen is 28.0134 grams per mole. So that gives us 0.72019 moles of nitrogen N2. And so now that we have moles of nitrogen and moles of air, we can get our total moles, which is our moles of air, 0.2559, plus our moles of nitrogen, 72019. And this gives us 0.9761 moles total. Now that we have our total moles, we can find our new pressure. And with the new pressure, we can find the force. And so to find the pressure, we do the ideal gas law, PV equals nRT. Pressures are unknown. Our volume is 6.283 liters. This is the total volume of the cylinder that we found first. Our number of moles we just found to be 0.9761 moles. Our R value is 0.082057 liter atmospheres per mole Kelvin. And our temperature is 298 Kelvin. And so we rearrange this to solve for P. P equals nRT over V. And when we plug in all of our numbers, we get that our pressure is 3.799 atmospheres. And so surface area, or here, let's go to a new page. Force is equal to the pressure times the surface area. We can calculate the surface area, but we need to convert our centimeters into meters. And we need to convert our atmospheres into Newton meters squared. So let's first find our surface area. That is equal to 2 pi r squared plus 2 pi rl. And so we can plug in our variables. 2 pi, our radius is 0.0010 meters squared, plus 2 pi times 0.0010 meters. Or I have too many zeros here. We have centimeters, not millimeters. And then our length, 0.020 meters. And this gives us a surface area of 0.188496 meters squared. And now our pressure is equal to 3.799 atmospheres. And when you convert that to Newton meters squared, you get 3.84934 Newton over meters squared. And now we can multiply these two numbers based on this equation to get our force, which is 72558 newtons. And we can convert that into pounds to get 1.6311 pounds. And that is our final answer.